Today we'll deal with heat. It's part 2. So today we'll deal with thermal equilibrium, and also we'll deal with temperature. Okay. Firstly, what is the thermal equilibrium? Thermal equilibrium means if we consider two bodies, as same example that we discussed in part 1. Here, let's consider it is object A and it is block B. Now, let's say this object contains 70 degrees centigrade and this block contains 100 degrees centigrade, right? So, the normal definition of thermal equilibrium is when two bodies were in contact with each other. Contact means they need to touch each other, right? So, when I place them side by side, which means they are touching each other. So, when two bodies were in contact with each other, what happens is there is a movement of heat energy takes place from body at higher temperature to body at lower temperature. As you guys know, here it is at 70 degrees centigrade, it is at 100 degrees centigrade. Now, what happens is the temperature might flow from body at higher temperature. If you consider 100 degrees centigrade is at higher temperature and 70 degrees is the lower temperature. Now, what happens is there is a movement of temperature takes place, that is heat energy transfer takes place. Now, if you consider in this case what happens is 70 and here 100 degrees centigrade movement. Now, what happens is there is a minus 10 degrees, let's consider it comes to 90, there is a 10, if we add it, it comes to 80 now. Now, if we subtract 5, it becomes 85, if we add 5, it becomes 85. Now, as the time passes, both the bodies gain the same temperature, that is 85 degrees centigrade and 85 degrees centigrade, right? So, if these two get the same temperature, we'll say the bodies A and B both are in thermal equilibrium, right? So, it is a very tedious process, right? So, to determine the value, we will simply use the average of these two, that is simply do 70 plus 100 by 2. It means 100 plus 70, it's 170 by 2. Half of 170 by 2 is nothing but 85, right? Still we get the same value, right? By using thermal equilibrium, it is very easy to calculate. That is just doing the average. For suppose if we have three objects, right? Let's say we have object A, we have object B, and we have object C, right? Three objects at different temperatures. That is object A at 20 degrees centigrade, object B at 40 degrees centigrade, object C at let's say 90 degrees centigrade. Now, what is the thermal equilibrium temperature? Thermal equilibrium means you need to put these three objects in contact, right? Firstly, you need to place these three objects in contact. Now, what happens is A, B, C were in contact now. Now, what happens is there is a transfer of heat energy takes place, right? Now, in this case, to do this, very simple. You need to do the average, which means there is only two objects, so we did average for 2. We need to add those 2 and divided by 2, right? In this case, we need to add these 3, 20 plus 40 plus 90 divided by overall substances, that is number of substances 1, 2, 3, right? You need to divide it with 3. We do it 90 plus 40, it's 130, 130 plus 20, it's 150 of 3. In 3 table is goes for, yeah, I think it's 50 times, right? 5 series are 15, right? So, it's 50. So, overall thermal equilibrium temperature for these three bodies is 50 degrees centigrade. 50 degrees centigrade. Now, in examination, they might ask you the question. They might ask you that questions like A is at 50 degrees centigrade, B is equal to dash if A and B both are in thermal equilibrium. Okay, they had given the temperature of A and they had asked you what is the temperature of B, but they had given us the hint, that is A and B both are in thermal equilibrium. If the two objects were in thermal equilibrium, what happens to their temperatures? Their temperatures must be equal, right or wrong? So in this case, B also has the same temperature, that is 50 degrees centigrade, right? It's very clear. So while doing it, I think you got to clarity about the thermal equilibrium now, right? If we have 4 objects means simply do the same thing, right? You need to add 4 and you need to divide it with 4. If we have 5 objects, you need to do the same thing. We need to add 5 and divide it by 5, right? So that's it about the thermal equilibrium. So in general, in our lifetime, okay, in general, day-to-day life, this thermal equilibrium is slightly useful. Let's say, for suppose if we consider the outside temperature, let's say you are inside your room, right, and it's a sunny day. If it is a sunny day, right, what happens is, let's say exactly the temperature, the time is 1 o'clock. 1 o'clock now. Now what happens is, the temperature is in peaks, I hope so, it might be 45 to 50, okay. In general, it is not an average, okay. Let's say it's 40 degrees centigrade. Now what happens here? If the outside temperature is 40, what happens to the inside temperature of your house? Okay, I am telling, if your house is not built with an AC, right? Now what happens here? If there is no AC here, what happens is, the temperature, because outside temperature is 40, inside also will get the same temperature, that is 40, okay. That's because what happens is, we are in thermal equilibrium with the outside, yes or no, right? We are in thermal equilibrium, but sometimes what happens is, if it is a roof houses or else we tend to see normal houses, right? Old aged houses. Those houses, what happens is, heat energy comes and touches the roofs, and heat energy just stuck over there, but only the air enters inside. So we cannot feel that much warm inside. But in general, we have a normal houses, right? It is roof houses right now. So these houses do not stop the heat energy. Inside also will get the same temperature. Yes. So it is also one of the example for thermal equilibrium. And also, if we consider one more example, let's say if you are sitting inside your classroom, right? For suppose inside your classroom you are sitting. Let's say this is your bench. If you put your hands on the bench, you tend to feel a little bit cooler in the beginning, right or wrong? In the beginning, you tend to feel little bit cooler, but after some time, your body, okay, your hands temperature and the table's temperature might becomes equal. Yes or no? Yes, that's because we tend to maintain thermal equilibrium. After some time, what happens is, your body temperature is higher than compared to the bench's temperature, right? So then the heat energy flows from your hand to the bench, right? So that is one more example. If you consider one more example, let's say if you consider you're standing here and you're holding a cup of tea, yes or no? In this case also, what happens? The tea has a higher temperature and your body has a lower temperature, because if it is hot, right? I am talking about the hot coffee, I am not talking about a cold coffee, right? If you consider this hot coffee, when you touch it, what happens? Okay, there is a need to be in thermal equilibrium, right? That is the reason heat energy flows towards your body. Then, but you won't allow that heat energy to enter it, right? That is the reason. So there is no thermal equilibrium required here. But always heat energy wanted to be in thermal equilibrium position, right? So these were some of the examples that are related to thermal equilibrium now. Okay, that's it.